One of the most difficult concepts that students and maybe even teachers like yourself have is the difference between temperature and heat. I'm going to try to do a demonstration to show the difference between the two. Let me begin with 100 mils of cold water, which I'll pour into each of these two styrofoam cups. Take it. So I've got 100 mils of cold water in the two styrofoam cups. I'm using styrofoam cups because they're fairly good insulators and prevent either heat gain or heat loss to the surroundings. Then I'm going to take two different masses of iron, and I've just used two nuts and bolts with a different mass. It doesn't really matter how different they are. I'm going to set them into a beaker and pour hot water that I've boiled in a kettle over them. We'll leave that in there for a few minutes to make sure that both of these bolts are at the same temperature. In the meantime, we'll measure the temperature of the water in the two cups. This one's at 15 degrees Celsius, and this one is also at 15 degrees Celsius. They're both at the same temperature, and by now both of these bolts will be at the same temperature as well. So let me take the smaller one out first, shake off excess water, and lower it into the one, and we'll do the same with the other. In which of these cups will the water reach a higher temperature? So it went from 15 degrees to 18 degrees. The one with the larger bolt went from 15 degrees to 20 degrees. This one went up 3 degrees, this one went up 5 degrees. What does it tell you about the amount of heat that each of these bolts contained? Well, the larger bolt, because of its higher mass, must contain a greater amount of heat energy, which was then transferred to the water, causing the water to warm up to a higher temperature. With the smaller bolt, not quite as much heat was transferred, and therefore the temperature did not go up quite as high. So, what is the difference between temperature and heat? Well, we often say that temperature is a measure of the energy of the particles making up the matter. We say it's the average kinetic energy. When they're at the same temperature, both substances have exactly the same average kinetic energy in the particles making up the substance. Now, because we have a larger bolt, it has then more particles and therefore is able to carry more heat energy with it from the hot water to the cold water in the cup. So, temperature is a measure of the average kinetic energy. Heat is a measure of the total amount of energy that is then carried by the substance or contained in a substance. I have here two beakers of water, a small one and a large one. Both of these are at the same temperature. Now, which contains more heat energy? Well, obviously, the larger one having A higher mass, a greater volume of water, will also contain more heat energy. This has the same temperature, and therefore the average energy of the molecules of water is the same in the small beaker as in the larger beaker. But because I've got so much more water here, the total amount of energy, which we call the heat energy then, is greater in the larger beaker than in the smaller beaker. In the same way, I could say that a teacup or a beaker of hot water would contain less energy than Lake Ontario, even though my hot water may be at 100 degrees Celsius and the lake only at 15 degrees Celsius. The total amount of heat energy in the lake is much greater because of its huge volume of water than the small amount of water in my beaker or in my teacup. So temperature and heat really measure different properties of a substance.